Hey everyone, welcome back. Ready to tackle some seriously big questions?
Always.
Well, today we're diving deep into the search for alien life. Are we alone in the universe? All that.
One of my favorite topics.
We'll be breaking down an interview with astrophysicist Adam Frank. He was on the Lex Fridman podcast.
Oh yeah, I saw that one.
By the end of this deep dive, you'll be able to hold your own in any conversation about aliens, I promise.
Let's do it.
So, where do we even begin with something this massive? I mean, the sheer scale of the universe, it's mind-boggling.
Right. It's almost impossible to grasp. But, scientists have developed some pretty amazing tools to help us think about this, to sort of narrow the search. You know what I mean?
Absolutely, yeah. Like the Drake equation, right?
Exactly, the Drake equation. Now, it's not some kind of magic formula. It doesn't give us a definitive answer, but
it's a framework, right? A way to think about the probabilities.
Exactly. It breaks down this huge question into smaller pieces, each one a factor in the likelihood of finding other intelligent life.
So, one factor is how many stars have planets, right? And thanks to all the exoplanet discoveries, we know that planets are incredibly common.
Practically every star we see in the night sky probably has a whole system of planets around it.
Which means
trillions of planets.
Trillions. Just think about that.
Yeah.
Trillions of potential places where life could exist.
It's incredible, isn't it? And yet, despite all those possibilities, we haven't found any definitive evidence yet.
Which leads us to
the Fermi Paradox.
Right, the Fermi Paradox. Basically, if there are so many potential alien civilizations out there, why haven't we met any yet?
Why haven't we even found any evidence of them?
It's a great question and kind of unsettling, too, when you really think about it.
It is. But it's important to distinguish between, there are actually two versions of the Fermi Paradox. The direct one, which asks, why aren't aliens here on Earth right now? And the indirect one, which asks, why haven't we found any evidence of them at all?
Okay, yeah, that makes sense. So, are we saying that the indirect version of the Fermi Paradox, it's not really a paradox because we haven't been searching for that long?
Right, exactly. Our search for, what they call technosignatures.
Technosignatures, like telltale signs of technology.
Right, those technosignatures. Our search for them has only just begun, really.
It's like we're just starting to dip our toes into this vast cosmic ocean.
Exactly. And think about it. Even if there were civilizations out there in the past, their evidence could be long gone.
Like buried under cosmic dust?
Yeah. Or wiped away by geological processes. There's this idea called the Silurian hypothesis.
The what?
The Silurian hypothesis. It suggests that even if aliens visited Earth millions of years ago, we might never find any trace of them.
Wow. It's almost like trying to find a whisper in a hurricane.
That's a great analogy.
Yeah.
And, on top of all that, we have to consider that we might be looking for the wrong things entirely.
What do you mean?
Well, our current methods for searching for technosignatures are based on our own understanding of technology, right? But what if alien technology is so advanced, so different from anything we can imagine, that we're completely missing their signals?
Oh, wow. It's like we're trying to find a radio station when we don't even know what a radio is.
That's a good way to put it. It really pushes us to rethink our assumptions.
So how do we even begin to search for something we can't even imagine?
Well, one approach is to look for technosignatures that don't require aliens to be intentionally sending us signals. Passive evidence, like fingerprints at a crime scene.
Cosmic fingerprints, I like that.
Right. So instead of waiting for a phone call, we're looking for clues that they've been there. And those clues could be pretty mind-blowing.
Like what? Give me an example.
Imagine a civilization that's so advanced that they've built structures around their star to harness its energy.
Whoa, like a Dyson sphere.
Yeah. Or even more massive, a Dyson swarm, thousands of structures completely surrounding a star. Something like that would leave a detectable trace.
Okay, that's wild. So we're not just looking for radio signals anymore, we're looking for evidence of megastructures.
Exactly. Or we might find signs of industrial pollution in the atmosphere of a distant planet.
So even if they're not trying to contact us, their technology would still leave a mark on their environment.
Precisely. Or think about solar panel glint.
Solar panel glint.
Yeah, like the reflection of sunlight off of massive solar energy collection systems.
Oh, that's interesting. So we're looking for something that could be pretty subtle, I guess.
It can be, yeah. But with new technologies, more powerful telescopes, we're starting to be able to detect these things.
And what about city lights? Could we actually see the glow of cities on other planets?
It's possible. It would be incredibly faint, of course, but maybe detectable with the right technology.
It's amazing to think that the evidence might already be out there somewhere in all the data we've collected from our telescopes.
That's right. And that's why scientists are now using artificial intelligence to help sift through all that data, training computers to be cosmic detectives alongside us.
That's pretty cool. So we're basically giving computers a crash course in alien hunting.
In a way, yeah. But even with AI, it's still a huge challenge. The distances involved are just, well, astronomical.
Right. Even detecting something as massive as a Dyson sphere would be incredibly difficult with our current technology.
True. But there are some amazing new telescopes in development that could change the game completely.
Like the Solar Gravity Lens Telescope, right? I've heard about that one.
Yeah, that's a really exciting one. It would basically use the sun's gravity as a giant magnifying glass.
Whoa, that's amazing. So we could actually see surface details on planets light years away.
Theoretically, yes. We're talking about resolutions that are thousands of times greater than anything we have today. We might be able to see continents, oceans, even cities.
That's mind-blowing. It's like going from blurry satellite images to Google Street View for another planet.
Exactly. Of course, it's still decades away, but the potential is just incredible.
It is. And in the meantime, we have the James Webb Space Telescope, right?
James Webb is already doing amazing things. It's capturing direct images of exoplanets, which is incredible in itself.
Yeah. I mean, just a few years ago, the idea of directly imaging an exoplanet seems like science fiction, and now we're doing it.
It's an exciting time to be an astronomer, that's for sure. And it makes you wonder, what if we're looking in the wrong places entirely?
Okay, you've got my attention again. What other possibilities are we overlooking?
What if the evidence we're seeking isn't out there in distant star systems, but much closer to home?
Closer to home, you mean like Mars?
Well, Mars is definitely interesting, but I'm thinking even closer. What about our own moon?
The moon? Really?
Think about it. The moon hasn't undergone the same kind of geological changes as Earth. It's like a time capsule.
Oh, I see what you mean. So remnants of ancient alien civilizations, evidence of their technology, it could be preserved there, just waiting to be discovered?
Exactly. It's a possibility worth considering, wouldn't you say?
Definitely. It's like instead of searching for a needle in a haystack, we're looking for a needle in a time capsule.
Precisely. It challenges us to think outside the box, to consider all the possibilities.
This is already making me rethink everything I thought I knew about the search for alien life. Before we go any further down that rabbit hole, though, I think it's time to take a break and let our listeners catch their breath.
Yeah, good idea. We've covered a lot of ground already.
We'll be back soon with more fascinating insights from Adam Frank's interview. Don't go anywhere.
As we're thinking about all these possibilities, it's interesting to consider that our very approach to science, the way we do science, it might be limiting us in a way.
Limiting us? How so?
Well, science, as much as we try to be objective, it often focuses on a very specific perspective.
A third-person perspective.
Exactly. We emphasize, measurable data, quantifiable phenomena, things we can observe and test.
Right, the empirical stuff. So what's missing from that?
The subjective experience, that feeling of being a conscious observer, being part of the universe.
I see what you mean. Like we're so focused on measuring and analyzing, we forget that we're part of the equation too.
Exactly. And this blind spot, this tendency to neglect the subjective, it could be hindering our understanding of some pretty big things, like consciousness itself.
And our search for alien life.
Exactly. We're defining life based on what we know, on our own biology, our own evolutionary history. But what if alien life is radically different?
What if it doesn't fit into our neat little categories?
Right. What if it's not carbon-based at all? Or what if it doesn't even evolve in the Darwinian sense that we understand?
Wow. It's humbling to think that our understanding of life might be too narrow, too focused on ourselves to really grasp the possibilities.
It is. And it points to the need for a more holistic approach to science.
Holistic.
Yeah, one that integrates both the subjective and the objective. We need to consider not just what alien life might be, but also how it might experience the universe.
So we need to go beyond thinking about just biology and technology and start considering things like consciousness, perception, even culture.
Exactly. Think about it. Their consciousness, their perception of reality, their culture, their art, all of these can be fundamentally different from our own.
It's mind-boggling, but also incredibly exciting. It really expands the possibilities of what we might find out there.
It does. And it raises some some pretty profound questions about how we would interact with such a civilization.
Like, how do you even begin to communicate with a species that might have completely different forms of language, cognition, maybe even a different understanding of physics?
Right. It's a question that often comes up in science fiction, but it's something we need to start seriously considering.
We need some kind of like cosmic first contact protocol.
Exactly. And it's a conversation that needs to involve not just scientists, but philosophers, anthropologists, linguists, everyone.
Because this isn't just a scientific question. It's a question about what it means to be human.
Absolutely. It's about our place in the universe, our responsibility to other forms of life if we ever find them.
And it's a question we might not be able to answer until we actually encounter another intelligent civilization.
That's true. But just asking these questions, grappling with these possibilities, it's already expanding our understanding of ourselves and the universe.
It's like we're preparing for a journey to a destination we may never reach. But the preparation itself is transforming us.
I like that. It's making us more aware, more thoughtful, more open to the unknown.
And maybe that's the true value of this search for alien life.
Maybe it's not just about finding them, but about the journey itself, about how it challenges us to grow and evolve.
I love that perspective. So we've talked about the challenges of searching for technosignatures, the limitations of our current technology, and the possibility of finding evidence closer to home. But Adam Frank also brings up another really interesting concept in his conversation with Lex Fridman, the Kardashev scale.
Ah, yes, the Kardashev scale. It's a fascinating way to think about the potential paths that civilizations might take.
It's all about energy consumption, right?
Exactly. It classifies civilizations based on how much energy they can harness. You've got planetary civilizations like us using the energy of their home planet.
Then there are stellar civilizations controlling the energy of their star.
Right. And then the ultimate galactic civilizations commanding the energy of their entire galaxy.
It's pretty mind-blowing to think about, especially when you consider how much energy we consume as a species compared to the vast energy of a star, let alone a whole galaxy.
It really puts things into perspective, doesn't it? And it raises some pretty big questions, too.
Like, can a civilization actually reach those levels of energy consumption without facing some serious challenges?
Right. Or what kind of technologies would a Type 2 or Type 3 civilization even have? How would they even view a species like ours?
It makes you wonder if the search for alien civilizations isn't just about finding life out there, but about understanding the potential future of our own civilization.
Exactly. By studying the potential paths of other civilizations, we might learn something about our own trajectory, the challenges we might face, the possibilities that lie ahead.
This is really turning into a journey of self-discovery as well. It's making me question not just what's out there in the universe, but also our place within it, our potential, our responsibilities.
And that's maybe one of the most profound takeaways from all of this. The search for alien life, it's not just about finding answers, it's about asking better questions. It's about expanding our perspective, challenging our assumptions, and ultimately understanding ourselves a little bit better.
Well said. I think we've covered a lot of ground in this part of our deep dive. We've explored the limitations of our scientific approach, the need for a more holistic perspective, the incredible possibilities of the Kardashev scale, and the ethical considerations of encountering another intelligent civilization.
And we've only just scratched the surface. There's so much more to explore in the realm of alien civilizations.
You're absolutely right. And we'll be back soon with the final part of our deep dive. We'll delve into some even more thought-provoking ideas from Adam Frank's interview. Stay tuned.
Welcome back to our deep dive on alien civilizations. Still so much to discuss.
Thinking about these incredibly advanced civilizations, Type 2, Type 3 on the Kardashev scale, it raises a pretty, maybe a slightly unsettling question.
Lay it on me.
Well, it has to do with the lifespan of these civilizations, how long they actually last.
Okay, so we're talking about, cosmic mortality rates.
In a way, yeah. What if technological civilizations, what if they're actually pretty common, but
they don't stick around for long?
Exactly. Maybe it's not that aliens haven't evolved intelligence and technology, but that they tend to, fizzle out, on a cosmic timescale.
So instead of picturing a galaxy full of these ancient, super advanced civilizations, we might be looking at a galaxy littered with, ruins. Yeah, kind of like cosmic ghost towns. And that makes the search even harder because
we're not looking for bustling cities. We're looking for whispers and echoes of what used to be.
Exactly. And it changes how we think about where to look for evidence, too.
Okay, so another one of those think outside the box moments. We've talked about planets, even our own moon, as potential places to find evidence. But what else are we missing?
Well, Frank suggests we consider asteroids.
Asteroids, really?
Yeah. If a civilization was advanced enough to, mine asteroids for resources or even build habitats on them.
There might be traces left behind. Wow, it's almost like space archaeology.
It is. Instead of digging in the dirt, we're looking for clues on rocks hurtling through space.
So maybe the next big discovery isn't going to come from a distant star system, but from our own cosmic backyard.
It's definitely a possibility, and it highlights the importance of, keeping an open mind, not getting stuck in our preconceived notions.
This whole conversation has been a great reminder of that the search for alien life, it's not just about pointing telescopes at the stars. It's about
imagination, about challenging our assumptions, about constantly asking new questions.
And even if we never find definitive proof of alien civilizations, just the act of searching has had a huge impact.
Absolutely. It's pushed the boundaries of science and technology, sparked countless philosophical discussions, and inspired generations to look up at the night sky with wonder.
It's a journey that's enriched our understanding of the universe and ourselves, whether we find aliens or not.
And who knows what incredible discoveries are still waiting out there. Maybe someday we'll finally answer that big question. Are we alone?
And maybe even more importantly, we'll learn something profound about ourselves in the process. That's the beauty of scientific exploration, isn't it? It's not just about finding answers, it's about the journey, the questions we ask along the way, and how that search transforms us.
Beautifully said. It's a journey that invites all of us to participate, to look up at the stars with a sense of wonder, and to never stop asking those big questions.
And on that note, we've reached the end of our deep dive into the search for alien civilizations. We hope you enjoyed the ride. Keep those cosmic questions coming, and until next time, stay curious.